Hello, today we're going to be looking at lesson 2-2, subtracting integers. One of the main things to remember is an integer is a positive or negative whole number. So we won't be seeing any decimals, we won't be seeing any fractions, but we will definitely be seeing positives and negatives. Another thing to remember is when we see the word subtract, subtracting really means the same thing as adding a number's opposite. We'll use that periodically as we go through some of these problems. So let's start with -7 minus 8. So if we automatically want to think of that as adding the opposite, then really we can change subtraction to addition and change the sign of the second integer. So it would become -7 plus -8. So if you're adding -7 to -8, we go back to our rules of addition. We're just adding two numbers with the same sign. So we add the numbers, keep the sign. 7 plus 8 is 15. We keep the sign, which would make this -15. So that's one way to think of it. Another way to think of it, if we go back to what the expression said from the very beginning, it said -7 minus 8. So if you think of it, if you're at -7 and you lose 8 more, you're certainly not going to go into the positives. You're losing an additional 8. You're going further into the negatives. You're sliding down further. And it's 8 more spaces, which would take you to -15. So a couple different ways to think of that one. Now in the second one here, we have 6 minus -6. 6 minus -6 is when we have one of those double negative situations. So again, we said subtraction is the same as adding a number's opposite. So if we wanted to take that into consideration here, we could change subtraction to addition and then change the sign of the second integer. So we would make this a positive. And so really this problem just becomes 6 plus +6, which is an easy answer of 12. So in this case, when you see that double negative in a row, minus a negative, it's always going to become plus a positive. And so the more that you see it, you'll get into that habit of remembering that that's really just going to imply addition. In this next one, we have -2 minus a -9. Now, something really important to remember. We said that when you change subtraction to addition, you change the sign of the second integer. Never will you change the sign of that first integer. So we see the -2 is the first integer. That's not going to change. However, the subtraction we can change to a plus sign, and the sign of the second integer then must change to a positive. So now this problem becomes -2 plus +9. Well, -2 plus +9 is almost the same thing as saying 9 minus 2. Because we have a +9, it's being increased by a -2, or in other words, -2 is being taken away. Another way I like to think of it is if you're at -2 and you're gaining 9, where would you end up? Well, if you're at -2 and you go up 9, you're going into the positives 7 spaces because you're taking that 2 away. So you take the 2 away from the 9, but we are in the positives now, giving us a final answer of +7. Okay, in example 2, we have a small word problem. But this word problem I think is really helpful because it allows you to see the vertical movement of the negatives, which you see on a thermometer. So on Valentine's Day last year, the temperature rose from -9 degrees Fahrenheit to 43 degrees Fahrenheit in an hour. That's a fictitious amount, but we have seen dramatic temperature changes certainly before it, especially living in Pittsburgh. How many total degrees did the temperature change in that hour? So we're looking at a vertical number line. So if that's really what a thermometer is. It's a vertical number line. So I want you to think about something. On a thermometer, if we have 0 degrees Fahrenheit right here, and we know that the temperature started the day down here, which was -9 degrees, and it goes all the way up here, we'll say, to 43 degrees Fahrenheit. So I want you to really think about this scenario. If we were to write this as a subtraction problem or an addition problem, really, when we're looking for how much something has changed, usually we look at the current value and we subtract the original. So that problem would look like this: 43 minus the original, which was negative 9. Now, we just learned or reviewed that 43 minus a negative really becomes, we change the subtraction to an addition sign, and we change the sign of the second integer, making this 43 plus positive 9. And so when we would add those two, we would get an answer of 52 degrees as the amount of change that occurred. But I want you to see this visually over here. So we were going from negative 9 to 43 on the thermometer. So what that means is the temperature traveled up 9 degrees just to get to 0. So when we're thinking of change, it had to go up 9 degrees just to reach the 0 degree mark. Then we had to go up an additional 43 degrees. So when you think of it that way, we have positive 9 degree change to get to 0, then a positive 43 degree change to get to 43. And so really, we're adding those two. We're increasing by that amount. And so that's really why a visual of why when you're subtracting a negative, it's really like you're adding a positive, because we're looking for how much change occurred. And really, change is a way to think of a subtraction problem, the difference in the two amounts. And so hopefully that visual helped you to see that a little bit. Okay, now we're going to move down and look at example 3 here. So in example 3, we have some expressions that we have to evaluate for a given value of the variable. So first, we see the problem says 5 minus 2 times the quantity, 6 plus f in parentheses, for f equals negative 1. So what that means is anywhere we see an f, we're going to have to substitute in a negative 1. And so when we rewrite this, we see that our expression will be 5 minus 2 times 6 plus negative 1. Now, from the beginning of the year, we've been talking about PEMDAS, and we've reminded you that it's not going to go away. This is another great example of that. We must follow PEMDAS throughout the entire process of evaluating this expression. So let's start with the parentheses. So within the parentheses, we have 6 plus negative 1. So we're adding a negative to a positive, so we're really just taking it away. So that becomes 6 minus 1. So now we would have 5 minus 2 times positive 5. The next thing that we're going to need to do is multiplication. So we will multiply the 2 by the 5, which will give us 5 minus 10. And then our final step is to subtract. So now we're subtracting 5 minus 10. Now, what's interesting about this is we're taking a larger number away from a smaller number. So we're still finding the difference of these two values, but we are going to go into the negatives, because if we're starting with a value of positive 5, but we're losing more than we have, we're going to go into the negative. So we will end up at negative 5. Because if we start with 5 and we lose 10, the difference of 10 and 5 is 5, so we're now in the negative 5 spaces. In this next expression, we're evaluating for r when r equals negative 8, and the expression is 3 minus negative 4 plus r. So that negative 8 will go in anywhere that we see an r. And when we rewrite the expression, it would be 3 minus negative 4 in parentheses plus negative 8. In the parentheses, which is where we have to start again, we have 3 minus negative 4. Again, minus a negative becomes plus a positive. And so in this case, we would end up with positive 7. Then the remainder of our problem is 7 plus negative 8. Well, we're taking in 7 and adding a negative 8 to it. So they are different signs. So when we're adding two numbers with different signs, we actually subtract them. This actually is very similar to the problem over here, 5 minus 10, because that's really the same as plus a negative 10. Here it's like 7 minus 8, which is the same as plus a negative 8. So if we're at 7 and we're losing 8 in value, we're going to go into the negatives, but the difference of those two is only 1. So we will be at negative 1. In example 4, we're going to simplify the expression, nothing to substitute in, no variables, but we are going to follow PEMDAS, of course. Now, if you notice in this problem, we only have addition and subtraction, and so we're just going to go from left to right in order to simplify. So let's begin with negative 12 plus 3. That's a negative plus a positive. They're different signs, so when they're different signs, we know that we subtract. So we would subtract 12 minus 3, but we keep the sign of the larger, which is going to be the negative. So it would be negative 9. Another way to think of this, if you're at negative 12 and you gain 3, you're moving closer to 0, 3 spaces, which leaves you with negative 9. Now we have negative 9 minus negative 2 plus 17. So we're going to focus on this negative 9 minus negative 2. Again, when we see the double negative, we know that subtraction changes to addition, and we switch the sign of the second integer. So it really becomes negative 9 plus a positive 2. Again, we're adding two numbers with different signs, so we're actually going to subtract them. The difference of negative 9 and 2 is 7. The bigger one was negative, so our answer will be negative 7. Again, keep in mind here that because we really started at negative 9 and we were gaining 2, you're moving a little bit closer to 0, in this case 2 spaces up, and so you end up with negative 7. And then the last part of this is to add 17. So we have negative 7 plus 17. They are different signs. We're adding different signs, which means we're actually subtracting. So we would have 17 minus 7, which is 10. This time the bigger sign is positive. And so our final answer would be positive 10. And again, keep in mind, if we started at negative 7 and we increased by 17, it would take us 7 movements to get up to 0, and then an additional 10 is where we would end up, which is why positive 10 is our final answer. In this last example, we also do not have any other operations other than subtraction, actually. So we're just going to move from left to right. So we will start with 6 minus negative 3. Again, we have the double negative. Subtraction changes to addition. We switch the sign of the second integer. 6 plus positive 3 is just 9. And then we have 9 minus negative 14 minus 20. So again, we have a double negative. So 9 minus negative 14. The subtraction becomes addition. We switch the sign of the second integer. Becomes 9 plus positive 14, which is going to give us 23. And then finally, we end with a very easy traditional subtraction problem where we're just taking a larger integer and subtracting a smaller one. So 23 minus 20, the difference of those two numbers is just 3. So our final answer, positive 3. Thank you.